concentration. So first of all, we need to know that many chemical reactions take place in solution. And concentration is basically a measure of how crowded things are. So concentration in solution is a measure of how much a substance is there per unit volume of the solution. There are two terms for concentration. The first one you need to know is the mass over volume. And mass over volume is how many grams of solute in 1 decimeter cubed of the solution. So concentration in gram per decimeter cube, which is mass over volume, will equal the mass of the solute in gram divided by the volume of the solvent in decimeter cubed. The second one is the moles per volume, and moles per volume is a measure of how many moles of solute in 1 decimeter cubed of the solution. To calculate the moles per volume, you simply divide the number of moles of solute by the volume of the solvent in decimeter cube. Notice that we always need to have the volume in decimeter cube. So if the question gives you the volume in centimeter cube, you have to change it first into decimeter cubed by dividing by 1,000. So as an example, what would be the concentration of sodium hydroxide solution when 20 gram of sodium hydroxide is dissolved in 0.2 decimeter cubed? Show calculation for both gram per decimeter cubed and for mole per decimeter cubed. First of all, it's very simple to show the concentration in gram per decimeter cubed will equal the mass, which is 20 gram over the volume of the solvent in decimeter cube, which is 0.2. So this is 100 gram per decimeter cube. So what about the concentration in moles per decimeter cube? We need to change the mass into moles. So we know that number of moles will equal mass over formula mass. So the mass here is 20. Relative formula mass for sodium hydroxide, when you do your calculation, it's 40. So the number of moles is 0.5. So we have 0.5 moles. Now we need to find the concentration in moles per decimeter cube. So the moles, which is 0.5 divided by 0.2, which is the volume. So you end up with 2.5 mole per decimeter cube. So this is how to do the simple calculation for the concentration in solution. In your exam, you will normally find questions asking you to calculate concentration in titration. So in titration, you find the volume of two solutions that are needed to react together completely. So if you know the concentration of one solution, you should be able to calculate the concentration of the other one. So let's have an example and see how we can do this and work out this. So the example here is if you have 30 centimeter cubed, so you can see here the volume is in centimeter cubed. When we do our calculation, we need to do the calculation changing this into decimeter cube. So 30 centimeter cubed of sulfuric acid of unknown concentration. So the sulfuric acid, we don't know the concentration of sulfuric acid, was titrated with sodium hydroxide. Concentration of sodium hydroxide is 0.1 mole per decimeter cube. And then the volume of sodium hydroxide that is used to completely react with the sulfuric acid was 25 centimeter cube. So what would be the concentration of sulfuric acid? Before we start working on this, we need first to write the balanced equation for this reaction. It's very important to have the equation balanced. So we have sulfuric acid react with 2 sodium hydroxide to give you sodium sulfate and water. If If you want to know how to balance your equation, please watch my video on balancing equation. I will put the link for this video in the description. So to do this, after writing your balanced equation, now you need to go stepwise in order to calculate your the concentration of sodium of sulfuric acid. So first thing, you need to work out the moles of sodium hydroxide in the 25 centimeter cube. We will use the equation, this triangle. So concentration equals number of moles over volume. And then now we need to work out the number of moles. So moles will equal C times V, so concentration times volume. And the volume here is going to be in decimeter cubed. The concentration term here is in mole per decimeter cube. So the number of moles of sodium hydroxide will equal C times V. So it's 0.1, which is the concentration, times the volume, which is 25 centimeter cubed. We need to change that into decimeter cube by dividing by 1,000, so 0.025. And then the concentration, the number of moles is 0.0025 moles. So the 25 centimeter cubed of sodium hydroxide equal 0.0025 contain 0.0025 moles. The second step then is going to work out the moles of sulfuric acid in the 30 centimeter cube. We know that 30 centimeter cubed of sulfuric acid reacts completely with the 25 centimeter cubed of of sodium hydroxide. So when we look at the reaction balanced equation, we're going to find that 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. That means the number of moles of sulfuric acid equals half the number of moles of sodium hydroxide at the end point, or at the completion, when the reaction is completed. So that means that 30 centimeter cubed of sulfuric acid will contain half this number of moles. So 30 centimeter cubes will have 0.00125 moles of sulfuric acid. The third step is to work out the concentration of sulfuric acid. Uh, to work out the concentration, we're going to use this equation, this triangle. So concentration will equal the number of moles divided by the volume. So simple, concentration will equal number of moles, which is 0.00125 over the volume in decimeter cubed, which is 0.03. So the concentration here is 0.0417 mole per decimeter cube. So this is how to calculate the concentration of the unknown using the concentration and volume of the known solution. We might also need to convert the mole per decimeter cubed into gram per decimeter cubed. So how can we do this to find the concentration in gram per decimeter cube? First, we need to find the concentration in mole per decimeter cube. In the previous example, we did this and we found that the concentration was 0.017. So the concentration, if we looked at the previous example, concentration was 0.0417 mole per decimeter cube. The next step is to use the equation mole equal mass over formula mass, or relative atomic mass, if we are talking about atoms, to find the mass equivalent to this number of moles. So first of all, we are looking at the mass here. So mass will equal formula mass times the number of moles. All right, so now we need to find the formula mass, relative formula mass for the for our product or for what we are calculating the concentration for, which is the sulfuric acid. So the formula mass for sulfuric acid, which is H2SO4, equals 2 times 1, which is the relative atomic mass of hydrogen, plus 32, which is the relative atomic mass of sulfur, plus 4 times 16, which is the relative atomic mass of oxygen. So in total, it's 98. So now we know that the relative formula mass of sulfuric acid is 98, and then we can calculate the mass because the mass will equal mR times N. So that's equal the 98 times N, which is the number of moles. So if the concentration is 0.0417 moles per decimeter cube, then 1 decimeter cube will contain this amount or this number of moles. So we put it as the 0.0417, and that will give you 4.08 gram. So this is how many grams we actually have in 1 decimeter cube. So the concentration then in gram per decimeter cube will equal 4.08 gram per decimeter